Welcome back to class. So before we went on break, on the short break, we were trying to solve this question. It says, find the gradient of a line passing through the points. You've been given the points P and Q. For P, you have the coordinates to be 1, 1, and Q coordinates to be 2, 5. Now, I was saying that gradient can be written like this, or like this, and this is the formula. y2 minus y1 over x2 minus x1. So let's name them. Now y2 is simply the y coordinates in this at the second point, or of the second point. So this is y2. Of course, this is x2, y1, and x1. So if we apply that, y2 is 5. So we have 5 minus 1. You see this? Over 2 minus 1. 5 minus 1 is 4. 2 minus 1 is 2 is 1. So 4 over 1 is 4. So the gradient is 4. Gradient, or the slope, is 4. So what's the answer? The correct answer is option A, which is 4. Now here we go. We have this question, very interesting question. It says, find the equation of a line that is parallel to y equals to minus 4x plus 2, and the line passes through the point with the coordinate 2, 3. Now, this is what we need to do. I have to teach you something here which is very important. Now, when lines are parallel, okay, I'm going to do that here. When lines are parallel, okay, you may want to write that somewhere. When lines are parallel, their gradients are equal. Okay, that is, if we have line L1 to be the same thing as line L2, what this means is that the gradient of M1 or L1 will be the gradient of L2. So look at the question again. It says it passes through, okay, the point 2, 3, but the line is parallel to y equals minus 4x. So y equals to minus 4x plus 2. Now the line is parallel to this line, minus 4x plus 2. Now that's quite simple. Now if you look at your equation of straight line, it looks like this. Y equals mx plus c, where your m stands for gradient and your c stands for the intercept, okay, on the y-axis. Now if you compare these two, you could tell that m is minus 4. Look at this. C is 2, m is minus 4, negative 4. Now, we're told to find a line, the equation of a line whose gradient is parallel. So the new equation we're going to find has this same gradient as this initial line given to us. So the gradient is minus 4. Now, if you have gradient, there are different ways of finding the equation of a straight line. One of those ways is what we call gradient and 1 point form, and that's what we're doing. Gradient and 1 point form. And that is exactly what we're doing. Now, we're doing the gradient. Now, we already have this. So, how do you find the equation of a straight line given the gradient and 1 point? It's quite simple. Now, this is the formula. Y minus y1 equals to m into x minus x1. So, we've been given the points. Now, these are the points. Here we have 2, 3. 2, 3. So remember that. So the point is 2, 3. Okay, let's go. So what do we have? This is x1, y1. So we're going to substitute. If you substitute, you have y minus your y1, remember, is 3, equals to the gradient, which we already did, minus 4, x minus 2. So let's go. This is y minus 3. If you clear brackets, you have minus 4x plus 8. So if we bring everything to the left-hand side, we're going to have y plus 4x because we have moved negative 4x over to the side. So we're going to move 8 as well. So we're left with minus 3 minus 8 equals 0. So y plus 4x minus 11 equals 0. I'm sure this one is easy. So 4x, y plus 4x minus 11. Y plus 4x minus 11. That's the correct thing. All right, so we're drawing closer to the end. Now let's look at number 38. It says if cot theta, it's actually cotangent theta, is 8 over 15, where theta is acute, find sine theta. Now the first thing to think about is, what is cot theta? All right, so before we start solving, cot theta is simply 1 over tan theta. Now, talking about these trigonometric ratios, okay, this is it. Now, 1 over cos theta is secant theta, while 1 over sine theta is cosecant theta. I'm sure this is clear. Now, it says theta is acute. Of course, you know what an acute angle is? An angle that is less than 90 degrees. So let's say this is what we have. And okay, I've drawn a right angle triangle because your trigonometric ratios work for right angle triangles. So let's say theta, 1 over that. Now let's go back to work. It says theta is acute. Now if 1 over tan theta is what cot theta is, then what that means, simply, remember we're told that this gives you, so 5 over 8, 8 over 15. 8 over 15. So this is 8 over 15. Now, what do you think tan theta would be? 15 over 8. Why? Because it's just an exchange. It's a reciprocal. Now, please note that the reciprocal of a fraction is simply found by changing the places of both the numerator and the denominator. So, if 1 over tan theta is 8 over 15, tan theta will be 15 over 8. Now, let's go here. This is theta. Tan is, you remember your SOHCAHTOA, right? Now, let's go. We can impute this value. Tangent, opposite over adjacent. Opposite over adjacent. So that's what this is. 8, 15. Now, but the question is, we should find another trig ratio. Find sine theta. Now, if this is what we have, we need to find what this long side would be. So let's call this side x. Now, from Pythagoras' theorem, x squared is simply eight squared plus 15 squared. Now, where did I get this from? All right. 8 squared This is x squared. This is Pythagoras. I was trying to write this down. Pythagoras theorem. Pythagoras rule. It says that the hypotenuse squared is the sum of the squares of the opposite and the adjacent. So if we have x squared, this would give us 64 plus 225. 64 plus 225 is 289. 289. Now, how do you find that longer side, hypotenuse? Square root of 289. Now, what do you think about the square root of 289? Now, the square root of 289 is what we need to find. And let me give you an idea. So if you do your math, do your multiplication, you can use your calculator if you have one. Of course, like I said, on your dashboard, or rather on your screen, when you're solving for JAMB, you will find your calculator there. Now, you have some simple mathematics work to do, some simple operations in mathematics, which you can do. There are some very complex mathematics operations that you cannot use those calculators for because they don't expect you to be able to do them using those calculators. So 289 is 17, just to be sure. So the square root of 289 is 17. So I'm going to come here and write x is x equals to 17. So I have this place as 17. Now the question says we should find sine theta. Now sine theta, from your SOHCAHTOA, opposite over hypotenuse. So the opposite is 15, hypotenuse is 17. So we could say sine theta is 15 over 17. So that is the answer to the question, 15 over 17. Sine theta is 15 over 17. So the correct answer there is B, 15 over 17. That is sine theta. Okay, well, we're gradually coming to the end of the class. Let's look at the next question. Still in 2010, question 41. Now we have come to calculus. Like I said, just go to YouTube. You can search for Prep Station on YouTube. I did justice to calculus last year and also statistics. So I just picked a few questions on calculus to solve, and we'll wrap it up from there. Now let's look at this question. Very interesting and simple question. It says, if y equals to x sine x, find dy dx. So I'm going to just introduce you to dy dx. When we say dy dx, we're talking about differentiation. So I'm going to teach you something on differentiation today before we solve this question. Let's just do a little recap. For some of you, it is new, especially those of you who have not been taking further maths. But it's very simple. Now look at this. Let's have this. So if you have a function of x to look like this, y is a function of x. Y equals to x raised to the power n. Now, if we differentiate y with respect to x, we're going to get, that's a rule anyways, nx raised to the power n minus 1. Look at this, nx. So the power goes down, and then you subtract 1 from it. For example, if y equals to x raised to the power 5, if you follow this example, okay, we're going to get y equals to 5x raised to the power 5 minus 1, which is 5x raised to the power what? 4. 5 minus 1 is 4. Now, this is the rule. This is the rule for differentiation. Okay, that's how it works. Now, but they are what we call standard differentials. Standard differentials. For instance, if you differentiate sine x, okay, if y equals to sine x, okay, if you differentiate y or if you like to say sine x, with respect to x, it will give you cos x. Now, if y equals to cos x, and we differentiate cos x, okay, that is, differentiate with respect to x of dx, this will give us minus sine x. Now, let's go. This is the technique of differentiation. With this, I think we're fine. Now, let's go back to the question again. It says, y is x sine x. Now, as part of the techniques of solving differentiation, there is what we call product and quotient rules. Product rule, product rule. So we have product rule, and we have what we call quotient rule. Quotient is simply when the functions are being divided. Now, for product rule, if y equals to uv, where u and v are functions of x, u, v, where u is a function of x, okay, and v as well is a function of x. Now, what this is saying is, when you have products, if you're multiplying two functions of x, there is a law or a rule. That's why it's called product rule. Now, so dy dx is equals to v du dx plus u dv dx. I don't know how this is, but this is what it means. Now, it means we're going to take the first function or the second function, differentiate the other one, plus take the other function and differentiate the other one. So that's what this is. That's product rule. Now, what if we have two functions, okay, dividing each other, as in this case, y equals to u over v. Now, there is a rule that says if we're going to differentiate y, this is how it works. We have v du dx minus u the v dx over v squared. V du dx minus u dv dx over v squared. Now, if we try to solve this question that we have with us, y is x sine x. We should find the y dx. So let's go. X sine x. So I am going to erase everything on my board now. All right. So the question is, y is x sine x. Now, if you look at this, there are two functions of x. This is one. Sine x is another function. Two functions of x. So we're going to use product. And of course, you know that they are multiplying. So we have y. So let u be x. Okay? And v be sine x. Now, if this works, I told you what to do for product rule. If you remember, you can go back. The y dx is simply v du dx plus u the v dx. Now, how do we mean? Now, we're going to differentiate u and v. So if u, already we have u to be x. How do we differentiate u with respect to x? That will give me 1. Now the next, if v equals sine x, if we differentiate v with respect to x, okay, the v dx, we're going to have we're going to have cos x. My apologies. We'll have plus x, cos x. All right, so we can put that together now. So dy dx is now v, which is sine x, du dx, can you see it? Du dx is 1. U, our u is x, okay? What do we have here? The v dx is here, cos x. So this gives us sine x plus x cos x. So that's the answer. Sine x plus x cos x. So let's go back and check. Sine x plus x cos x. That is option A. All right, at this point, we're going to take a break. We'll be right back.